Hello? All right.
1, 2. Okay, I think that we can start. Sorry, we are full, so please don't go in. So, okay, welcome everybody to this first session of the morning. We are here with Daniel Hervas, who will talk. Sorry, the room is full. It's full, so please. I know. Okay, thank you. Sorry. So, Daniel Hervas will show us the best practices when working with the Python containers. So, please, if you have questions, use Slido, and the stage is yours.
Yep. All right. All right. So yeah, hello everyone. Thanks for the full room. There's a side right here if anyone wants to. Yeah, well, today we're going to talk about containers, and the first thing I'm going to do is I'm going to be a bit meta, not as in the company, like I don't want your information, but in the sense of that I'm going to talk about the talk a little bit, or rather about the topic. So the thing with writing good container files is that it's very, very verbose, which makes it very unappealing, and it makes it easy for people to want to skip and take a shortcut. If you're going to do that, I highly, highly, highly recommend you use Jan Smitka's Docker files. Well, he had a talk last year in EuroPython. Excellent, excellent talk. Highly, highly recommend you watch both the talk and take a look to his Docker files. Very, very high quality, and insofar as possible, I will try to make my talk complementary to his, because I just couldn't do what he did better. So if you're going to just take something, take that. But I also want to bring to your attention that this random Docker file that I picked has 101 lines of code, which is absolutely like preposterous for something that's not actually code. And also the fact that many things that you will find in articles, in Medium, stuff like that, is actually very much wrong and dangerously wrong at places. So also, by the way, AI doesn't really help. I've been very nice to it, I think, but it still hasn't given me a totally good Docker file. It's not entirely terrible, but we will figure out in which ways this can be improved. Here's a larger kind of print of said Docker file. By the end of the talk, you'll know how to improve upon this. Not the worst I've seen, but actually we can do much better. So, insofar as possible, I will try to give you information that I think hasn't been given before, or that is not as easy to find. Part of the reason why is that, as you see here, if you take the first page of the kind of the Docker documentation, and you go to best practices, the number one thing is multi-staging, which is totally fine. You should know about multi-staging, and it's important, but it would be terribly condescending for me to go and tell you the first thing that comes into the docs. I think you don't need anyone to tell you that, and certainly not, you can do that by yourself, right? So I will try to give this talk kind of a different spin. For this, I will try to argue for good practices by kind of playing devil's advocate for a little bit. So I will try to justify skipping on all of these good practices, or I will try to argue for bad practices in a way, or at least try to get through the correct implementation, or just in general the correct way of doing things, through a kind of Socratic way of, in a conversational Socratic way, let's say. You'll see what I mean in just a second. In this manner, my hope is that instead of giving you kind of just a file that you can plug and use, that you more or less widely understand the principles of what makes something good and what makes something bad, so that if you take and copy something, you at least know what you're standing on, and that if tomorrow the syntax changes, you already know what makes for something that you should do and what you shouldn't do. So, since the talk is in Italy, I thought I would localize the talk and make it a bit more engaging by including some of the most famous Italian characters in recent history. So I have tung 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 sahur. I'm really glad someone actually got this reference. It would have been terrible if no one got it. But so he will play devil's advocate. If you see this guy on screen, it means don't actually follow what he says. I'm just being intentionally sort of misleading. And also, this is kind of, I mean, this is not entirely related to the talk, but someone wrote like a wiki page, and this guy has superpowers or something. It was just very funny to not include. The amount of weed that you have to smoke to come up with this bullshit is just insane. So this was very funny. And of course, the actual good practices guy, you know who it's going to be. The one and only tralalero tralala. So every time he appears on screen, you know that this is more or less what we are arguing for. So, seeing this, I have first two kind of, I only have sort of two principles to follow. As you saw, the good Docker files are hundreds and hundreds of lines long. I think just if you take away two things from this talk, it will be more than enough for you to understand what makes something good and what you should be striving for. And one of them is applying the principle of least privilege. This is something that's fairly common sense and applies in a wider scope than just Docker containers. But it also should apply to Docker containers. And you might argue against this. You might say, wait, why should I care so much about, I guess, in container security? It's an isolated environment. I don't really care what's inside. If you break into it, well, it's you can think of it as a virtual machine and you're kind of boxed in. So why should you care so much, especially if I have to bother about including all of these directives to make it safer? Well, it turns out that you can actually, you can argue against this. Containers are not really bulletproof, and you shouldn't think of them like that. You can leak a lot of important information. There can be vulnerabilities in the runtime. You can never really count on things being as safe as they would ideally be. So it's just in general a very good practice to try to scope down the permissions that your container will have, even in a container, right? Also, some compliance and security policies might be broken if you don't do this. So you might get fired, and I'll tell your boss and all of that. No, I won't, but OK. So, so in order to do this, the way to achieve this is by using the user directive. This makes it so that you do, well, it does more or less what it says. It changes your user. The thing is, many images do already have a preset or predefined user that's not the root one. However, this usually happens in prepackaged applications or such. So if you pull like the Airflow image, you'll have an Airflow user. The Python images that you'll find in Docker, in the Docker Hub, are not really serving any application. They're just for you to use. So they don't set a user separate from root. That's kind of delegated up to you. And this is how you do it, and this is what you should be doing. It's very good practice to create a user for the application and switch back to the root only for things like updating the system packages. This way, well, the environment in which your container is executing only has certain permissions over your application, but not about all the container system. And another suggestion kind of tied to this that I have, or at least tied to the entire rootless versus rootful conversation, even if it's outside of containers and not inside, is to maybe give Podman a try. This is, for those who don't know, it's you can think of it as a more or less a drop-in Docker replacement. And it's reached more or less feature parity. Maybe 5 years ago or so, it was still a bit inconvenient to use. Some features were not as advanced, and you would have things like performance issues and weird quirks and bugs. I think those times we're past them, I think, at this point. Podman is a reliable tool, and the trick, or why it's relevant to this part, is that it's rootless by default. So when you run a container, instead of talking to the systemd or service that's spawned by root, Podman forks off of your user space. So the container that you're running doesn't have permission over the entire file system, or just the entire, let's say, operating system, as hypothetically a Docker container could. So this can be useful for development. I find that it's really useful for knowing when you're abusing unknowingly your root privileges. For example, one common case, or at least it has been common for me, is that you're mounting a volume locally in your machine, and then later when you try to delete the folder in which that volume is mounted, you find that you cannot, and you have to use root because the folder has been created by Docker, not by your user. That's kind of common, and that's something that's inconvenient, and also that points to you abusing your super user privileges without really knowing that you were doing it. Podman will not allow you to get away with this. It will just not work. So maybe give it a try. It's not, I mean, Docker is fantastic, and Podman just works as well. So pick whichever you like the most, but it's an interesting project that may be worth checking out. Then the other big principle that I have is that the smaller your container, the better. Normally, these types of large statements or generalizations tend to be not entirely correct. For example, not necessarily the shortest code or the less lines of code is always better. So why should the less size be better, right? Well, it turns out that this generalization is, for the most part, a very, very good rule of thumb. You might think that that's not the case. By the way, that's a real video thumbnail right below that. That's like a real YouTube video that I, of course, haven't clicked. So you might think, why do I need to care about size so much if storage is cheap, network transfer speeds are very high, and why do I care about like 100 megabytes here or there? It's like we have terabytes of storage and a lot of gigabytes of network speeds, right? Well, it turns out that you should care about size because it scale, especially at scale, you do notice these differences. The most important point, perhaps, is that the smaller container is by default and by definition safer. The less applications you're bundling in your container, the less surface area you have for attacks. Also, and as I mentioned, you will notice this more at scale, but this is generally true. It is cheaper and faster to have smaller containers, especially if you're deploying something like if you're deploying from a registry, those pool times, if you're deploying a lot of containers, you will start to notice them. The cost is noticeable, especially if you're doing cross availability zone type network pools. And the spin-up time also is relevant in the case of size, even if it's a relatively small change. So you should care about it. So in order to know how to reduce the size, I will briefly go over the base images that we have for the Python kind of Docker hub. To sum it up, the preferred one has usually been the slim variant. So the slim variant is a kind of trimmed down Debian image. I think it's a very good compromise between size and conveniency. It's not as inconvenient as Alpine, but it's also it's also very much reduced versus the kind of more bloated standard Python image. Which, if you read actually the Docker documentation and you read the page that they have in Docker Hub, they do recommend the big one. it feels a bit kind of self-indulgent to criticize that. I mean, the people who have written that surely have the reasons, but I think that by all means, like in 90% of cases, you do want the slim variant, and then add whatever you need after. And then we're going to talk about Alpine, and this is where I will slightly go against the grain. Many people who are very good with containers will argue that you shouldn't use Alpine, that it's not worth the trouble. So there are some caveats that you need to take into account. It can be slightly slower. Some wheels might not be available, and it's rare, but it could happen that if you're making heavy use of C, something might not entirely work. However, I've come to find that the support overall has gone way better. We have way more wheels in Alpine now for different architectures. The image is, well, it is smaller, so there's a small gain to be made there. And if you're not doing, well, networking issues have been more or less solved. This used to be a thing, especially in Kubernetes environments where people would have problems with Alpine. This is now a thing of the past for the most part. And even though you need to take these things into account, and for highly specialized software, if you're doing something like data science, machine learning, or you need very high performance and very specialized programs, in that case, I would just recommend the Debian one. But for normal web development stuff, and you see a list of dependencies right there that I have in an application in which I'm running Alpine, and you might think that, well, that's pretty stupid, you have nothing. But that's kind of my point. If you are not doing anything special and you don't have any particular need for anything C-specific, I don't think that it's too bad using Alpine. I think you can get away with it, and it just works. So in these cases. So my suggestion is maybe give it a try. It's maybe not as bad as you would have expected it to be. Then I want to talk a little bit about updating the base image. So what I mean by this is using the system's package manager to update the operating system, right? So running apt update before doing anything. Now, should you do it? Because many people don't, including GPT, as you saw. And you can very reasonably argue against it. It, in fact, goes very much against a lot of the things that we have said are good. It will take longer to build the image. It will take longer to download these packages. The image may be more bloated. You have to write a lot more kind of code in the Docker file to deal with this. You lose in potency, which is kind of a reasonably big deal. This means that if you don't modify the operating system and you just copy the code over, you can realistically take the same image 20 years into the future and or the same Docker file 20 years into the future, and the image resulting container would be the same. If you do update the operating system, that's not true. If you update, if you build the image 1 week later, the resulting, the output will be different. And you can also argue that, you know, why should we care about this stuff? It should be upstream who should be providing us with all these security updates. Why is this delegated to the developer? So in order to kind of argue against that, I've taken a very empirical approach. What you see there is the latest Python image at the point of taking the screenshot, which was might or might not have been like 1 hour ago. And you have this image in the Docker Hub. What I've done is I've pulled that image, and I've written the dumbest Docker file of all time. You can see it right there in the image. It just takes the image and runs apt update. So now what I have is both the Python 3.13 image that was pushed a week ago and an image which is the same but just with operating system patches applied. And what I've done is I've run the Trivi, which is a very well-known vulnerability analyzer, open source. And what you see there is that more than 20 vulnerabilities. Don't be afraid of like the bash piping and stuff. It's just to kind of show the point. more than 20 vulnerabilities have been fixed by this process. And this is just in 1 week. So I think this more or less proves the point. Yes, it's inconvenient. Yes, you take longer to build the image. But in the end, I think security trumps all other concerns. And I would recommend that you include the operating system updates in your Docker files just for this very reason. Also notice that these are critical and high vulnerabilities, so we're not talking about minor things, right? So in the end, I do recommend you do this. And now to finish up, I have a couple more miscellaneous comments, tips, etc. That again, I hope you haven't seen before. If you have, well, sucks to be you. But if you don't, maybe you get something out of this. I really have a pet peeve with this command. It's really dumb. So in many of these images that I mentioned that you will find in articles and such, and if you blindly copy-paste, you will see this Python don't write bytecode environment variable. Don't do this. It doesn't work. It's really dumb. And in fact, well, our friend Conrad had a talk yesterday about bytecode, which I find it was extremely interesting. If you didn't get the chance to attend, I highly recommend you watching on tape. And he actually recommended kind of doing the opposite of what this variable does. So he said maybe it would be interesting for you to run the compilation before so that you have your bytecode already compiled by the time the image starts. If you set this environment variable, what it does is essentially postpone or delegate to some degree the generation of bytecode files. And yes, you might have a slightly smaller image size. What it will happen is that these bytecode files will get generated when you hit imports. So you will have big latency spikes in your servers when you hit that code path. It's just very dumb. You shouldn't really scrape to these lengths to reduce image size. It doesn't benefit anyone. Don't do it. Not worth it. If you want to know more, do check out the article in the QR. They explain it in much more length than I can here. Highly recommend that article. And yeah, don't do this. Finally, prefer copy over add. I think this is well known. But just to reiterate, add does more things than just copy. So it will kind of download files, extract files, etc. And you can kind of trap your fingers a little bit with it. It's not necessarily risky, but it's kind of a loaded command, and it's not as transparent as you might think it is. For this reason, I think copy is generally preferred. Copy is just more transparent, does what it says, and you have less risk of side effects by using it. Again, there's another very good article by Docker on this that you can reach via the QR. And these are just more kind of random flags, commands, et cetera, that you might not know about and you might find interesting. And that's it. That's all I have for today. Thank you.
No, okay. Thanks. Thank you, Daniel, for the talk. So we have time for a couple of questions, and there are a lot of questions. So the first one, as developer, I'm waiting for Docker builds on the CI all the time. We're using Kaneko. Do you think it's still a relevant build tool? Which tool do you suggest to build images fast in CI?
Well, I don't know much about that particular tool. I would say it highly depends on your general infrastructure. So in some instances, you might be forced to kind of cooperate with your cloud provider in order to have a faster CI. I have been forced, let's say, to use Azure DevOps in some instances, which also, funny enough, has some problems with caching. So I would say it highly depends. I don't think, well, I'm not an expert on all the different tooling. I just use whatever I'm kind of necessitated to. I will say, in general, the two things you want to be on the lookout for when you're looking for faster build times in CI is hopefully making a smart use of caching if every build is actually treated as an independent build and you have to pull everything all over again, it's going to be very slow. So watch out and try to rely on some caching mechanism if possible. And the second is to just have a clean Docker file again. So more or less what we've talked about before. Try to not have a very bloated image, and that's where you'll get a lot of gains. And make use of multi-staging whenever possible. If you can parallelize some build steps, that will highly increase your or highly decrease your build time if you can apply it. Other than that, I guess just generic tips. But no, I don't know that particular tool. So, yeah.
Okay, so next question is, should production images contain also the unit test dependencies?
Excellent question. No. So so in general, what you want to do is in order to have a really clean and perfect, and this is again something that takes a bit of time investment, a couple of lines, and that you might not be bothered to do depending on how much you care about these things. But the ideal situation would be that you have either different Docker files or even cleaner different stages to do these things. So you would have a stage that kind of prepares your code, and you would have a different stage that has whatever is necessary strictly for the tests. And in your testing battery, or however you are setting up this testing framework, you would only drag into the final image the specific test things, and those would be completely separate from the production image that you would that would be exempt from those specifics. So no, hopefully or ideally you won't, and you are able to do this via different Docker files or multi-staging. Choose whatever you think is more syntactic, but I would recommend to look into it.
Thanks. So do you have any opinions about UV's pre-built Python images?
Well, that's so no, I don't have any opinion, but and I'm gonna go on a slight tangent here because it's maybe partially relevant. So last year I got to speak with Pablo Galindo and Lucas Langa. These are CPython core maintainers and very famous. I'm sure most of you know about them. And I got to ask them a similar question, which was about UV's precompiled Python binaries. So in case you don't know, UV pulls precompiled binaries, whereas, for example, the virtual environment module links to your system's Python installation. UV will actually pull a precompiled binary from wherever and put it in your project. So I asked them about it, and I said, well, what do you think about this? Because they are serving, I mean, we trust them, and I'm pretty sure it's fine, but they are kind of serving a precompiled thing, and Python itself doesn't have it. So what do we do about this? Like, is it just okay? Do you plan to serve some precompiled variants of your own? And the answer was, yeah, we don't bother to do that. It would be kind of too much work, a bit inconvenient, and it would have some maintenance that we don't want to do this, but we fully trust these people to do things properly. We think it's totally safe to use, and we are totally fine with it. So I would say the images, same thing, I'm pretty sure applies, because we're talking about the same group of people doing, in this case, a similar thing. So yeah, I don't have an answer for that, but people who are better than me kind of do for a similar topic, and it should be totally fine.
Okay, thank you. We have time for just one more question. So, Canico is no longer maintained. Google withdrew all maintainers. Is Docker build kit the unprivileged future for builds on K8s?
Again, this is, I guess, this is related to the other question, which I sort of already didn't answer. So yeah, if you have another one, I think for yeah.
So updating the base image still results in the CVs being present. Shouldn't every company offer single snapshot, up-to-date base images? Idempotency is king.
Well, yeah, that's a very tung 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 sahur type argument. yes, it's true. Updated images also have CVEs, but some of these you have to take into account that they might not have, they might not be fixed upstream. The fix might just not exist yet, and they might be reported, but there's no way of getting a safer image because it just doesn't exist ever nowhere. So yes, I do think that at some point we will evolve to a point where a kind of live patching system or a safer manner of having those images up to date will be built into the system in some way, because this is kind of an important thing, and it's kind of dangerous, and this is happening everywhere. So I think we will get there, and this should happen. Unfortunately, so far it doesn't, so you're kind of forced to do this, so do it, I guess.
Okay, thank you, Daniel. Thank you. Sorry, I'm not an expert on this, so
No, no worries, no worries.
I didn't catch the part that you were questioning.
Okay, good morning to everyone, and I'm very happy to be here to present our next speaker for this session. There are two speakers in this session, Arthur Pastel and Adrian Cacciaguerra, that they present us your talk that is intuition versus reality, surprising truth in Python performance.
All right, thank you all for coming. So yeah, the talk is named Intuition versus Reality, Surprising Truth about Python Performance.
Just 1 second, sorry.
So first we're gonna a little introduction. So I am Adrian Cacciaguerra, and this is Arthur Pastel. 2 years ago we created CodeSpeed, and we've been working ever since on it. Arthur is having a bit of trouble with the slides. They'll be coming shortly. And yeah, the idea for this talk is going to be interactive, so be sure to have your mobile phones ready, because you'll have a QR code to scan, and there will be an interactive quiz, and there will be a leaderboard as well, so be sure to have them out.
Anyone knows the hotkey to... Thank you. It doesn't work. Great. Okay, we'll do like this. It will be fine. Okay. So you did a good presentation.
Yeah,
already.
a quick presentation of who we are. So to talk a bit about CodeSpeed really quickly, CodeSpeed is a dev tool that's aimed to measure and optimize performance before production. It's integrated with existing benchmarking libraries in multiple languages, but in Python it's integrated with PyTests. It can run on any kind of VMs, even GitHub runners, the free GitHub runners. And it consists in giving you performance report directly in your PR, so that if you have regressions or performance improvements, you'll see directly in your PR. You can see a small example in the next slide. So this is how it looks like in your PR directly. Whenever you open a PR, you have a performance report. So here it's an improvement, for example. Really quickly, we've been used by a lot of tools, Python tools in the community, so really grateful for that. It's free for open source.
The biggest benefit is that since those are mainly building blocks, speeding them up or making sure that actually they never slow down is good for everyone, because it makes sure that when you're using any library, may that be UV, Rough, or any as well runtime libraries like Pydantic, you're sure that actually it's not getting slower, or if it's getting slower, there is a good reason for that. So this is why we are really interested in bringing this free for open source to make sure the ecosystem stay as fast as possible.
Yeah, and next, we'll quickly gloss over this, why performance matters, a few reasons. The first one being that it's directly linked to user experience. If your website, if your application is faster, you'll have more usage, more retention, and it oftentimes leads to more revenue. For a lot of companies, performance is a feature. They need to be fast in comparison to their competitors. If you can do things faster, you can do more things, so you have less costs. And there is also a nice thing about sustainability, is that if you reduce the load in the data center for this exact same code, it's better because it uses less energy.
And now, as well, something that we'll try to show you today, and probably you already experienced, is that guessing performance or just trying to feel how performance will behave and how software will be executed is really hard. And even when we have some intuition, it can be right sometimes, but as well, you have some cases where it can be totally wrong. And this is what we are going to try to show you today. And so the way we're going to do it is with the performance quiz. So if first you need to log into the Wi-Fi, or if you have mobile data, it's fine. And then you need to go to aslide.com/codespeed, so basically what's written at the top, or you can scan the QR code as well. And so we are going to present you with multiple snippets of code. And the idea will be to guess which snippet and which piece of code is actually the fastest. And so we are going to start with simple examples to go to bigger and wider example covering more topics. So anyway, normally we can keep. We can start with the first one, and then I can put back the QR code, so you will still be able to log in. But otherwise, it's slide.com/codespeed. So the first one is about sleeping, so it's a bit of a warm-up. So basically, we have 2 sleep functions, one that will sleep for 1 second, another one that should sleep for 1,000 seconds. It's not using the same sleep, so be careful. And yeah, so every time you will have 10 seconds to answer, and the idea is that the fastest, and there will be a ranking at the end, so we have a leaderboard, and there is not just like the amount of right answers you will give, as well the how fast you are will give you more points. So the fastest will win.
But don't make mistakes.
So we can start this one, and it should start. And so yeah, every time you will have like 10 seconds, and it will be like this. So normally on your device as well, you have the code. So if you have any trouble seeing it on the screen, it should help. And so now we should have the answer. And so the actually fastest one was sleep 1,000. Good job. And so yeah, this was mostly a tricky question to start. But the idea was we're having an async function, and we are using async.io.sleep without awaiting it. So it's not even running in an event loop, which means that basically it does nothing. It just creates a future, and the function returns. So yeah, completely ineffective contrary to the other one that's actually sleeping for 1 second. So I promise this is the only way. This is the only one that is tricky like this and not that interesting.
Yeah. So the next first interesting example will be to count even numbers in a list. So we have 3 implementations. They all have the same signature. So we take a list of integers, and we return the number of even in that list. The first one uses a for loop. The second one using the sum operator with a generator. And the last one is using the len function with a list comprehension. For this test, what we did as an input is that we have a list of size 10,000 with random integers. So again, you'll have 10 seconds to answer, so be sure to answer quickly. Nice. I see that now we have more answers. Great.
Nice. And so, okay, time's up. And so the fastest, the actual correct answer was countlen. So the third implementation. And you guessed it was sum. So mostly a more clever one, let's say. So here are the benchmark results. So we can see that still it's pretty close. And for like the first difference between the sum and the for implementation is like really probably less than 10%, while the len one is really, really faster. And so,
yeah, the first reason why count sum can be a bit longer is that we are switching context between the sum operator and the generator. So there is a lot of back and forth during the execution of this code. And the next one. Yeah, and here there is an overhead in the for loop. There is an overhead due to the context flow, the control flow, sorry. We have a lot of conditions, and we are, again, kind of switching context between different parts. And we didn't show the fastest one, but basically with the len example, we only retrieve the len of an array, which is a really, really small operation.
And so for the next question, it will be on the same snippet of code. So as of now, we only talked about performance and execution speed. But something as well we need to consider is the memory usage and memory footprint. So we have here, we'll have another question, which is basically which of those snippets is using the least amount of memory. Maybe it was a bit fast. And yet
so the fastest one in terms of execution speed is the one that uses the more memory. You can see the results like by a lot. Basically, the idea is with the fastest example is that we are creating the whole list again, and then we are retrieving its length. So basically, we are creating a new list. So that's why like the memory usage is basically the size of the list. And for the other ones, since for the count 4, we are only iterating through the list and creating a counter. So in memory, we do not store, we barely store anything. And it's kind of the same for the sum and the generator, because we are generating a generator, and for each, and basically we are iterating. It's kind of the same thing. We are iterating through each of the list element.
And so for the measurement technique we used, so we could have used a memory profiler or like some more complex tools, but actually there are some Python built-ins that are really, really handy to trace and to measure the peak memory usage. So for example, you can use a trace malloc like this, and it's really, really not easy to set up, but if you go to the documentation, basically you will find a snippet really similar to this. And so in matter of minutes, you can get started and have a memory measurement tool directly in your code base without installing any library or anything. So it's really, really handy. And so, yeah, the learning here for this snippet is that here we got a really fast execution speed as a trade-off of the memory cost. And so often you can really increase the amount of memory you use and reduce the execution speed, but it really depends on the kind of application and where you think your library will run mostly, and if people, for example, will have some memory constraints. So in the next case study is on string concatenation, so a pretty simple operation that probably everyone already did. And here we have a first naive implementation using a for loop, and basically we iterate on the array of strings we have, and we concatenate it to the original result string. And the other one is using is a more Pythonic approach, using the join built-in method. And here, for this benchmark, the input will be of size 5,000 with random strings from size 1 to 16, so it shouldn't change really anything to the result, but we prefer mentioning the details of the input. And so in 5 seconds, you will have 10 seconds to answer and pick the fastest one.
Yeah, most of you got it right. Congrats.
Nice.
And it's by a lot. If we can see the benchmark result, like the difference between the two is quite significant. And the reason for that is mainly because for the concat plus, what we are doing is that we are each time for each string in the array, we are creating a new string, and we are copying a new string into the memory. So basically, we are creating a large number of strings in the memory. And why it's less it's slower than the other one is that because in join, basically join is a built-in function which is greatly optimized, and before doing any kind of operation with the strings, it basically looks at the array you pass to the join command, and depending on the length of that array, it will directly allocate the memory buffer in the memory that is approximately the right size. So we are basically not allocating the memory a lot of time, but only once. So that's why we have a strong difference in the execution speed. And yeah, the learning here is that the first example was slow because of string immutability, because every time we were adding a new string, we were creating a new one. And using built-in functions from the standard library is oftentimes a good idea in terms of performance because they are already well optimized.
And so the next case study is on two different patterns. So the first one is using a list comprehension, so probably the most Pythonic one, compared to the other using a list, the list constructor and a map, applying a lambda function to an array of data. So the second example is mostly really canonical if you're using JavaScript or other more functional languages, while the first one, I mean, it's probably the most common usage of list comprehension in Python. And so here we have a fairly big list with random integers from 0 to 9,999. So let's go. Okay, so we can start with this question. So in 5 seconds, again, which one is the fastest? And so you got it right. So the most idiomatic way to write this and implement this in Python is actually the fastest compared to the list map, even though here it's exactly the same. List and map are actually as well built-in functions implemented in C, so directly in the interpreter itself for CPython. And so here we have the results. So again, the difference is not that big, but still it's fastest if you're using a list comprehension. So the idiomatic way to implement it is the best one. And so if we talk about the reason, it's mostly about how it's implemented and what's happening with the lambda function. So here, if we have a look to it, so basically we disassembled those two functions. So it's pretty small, and then there are a lot of bytecode instructions. So to quickly sum up, basically a bytecode is the low-level language used by the Python virtual machine in CPython to run the code. And so instead of, for example, if you compile a C program, it will be compiled to assembly, x86 mostly, or ARM maybe. And then this will be run by the CPU. Here in Python, basically, your code is compiled to bytecode, so like this. And it will be run by the CPython virtual machine. And so here, we have the disassembly of those two functions. So on the left, we have the list comprehension. And we highlighted here in orange, basically the for loop. And so the core part that will be really hot when we are running the code. And on the right, we can see really less bytecode instructions using mostly built-in functions. So we can see the two first operation is loading list and map, so two built-in functions. And then they are called. But the tricky part is that when actually when the map operator has been created, then there are a lot of back and forth between the map object and the actual list constructor. And so all those back and forth will create a lot of context switching from the part that's actually building the list and the part that's actually running the lambda function. And so this has a cost, and this is what we are paying when we are seeing the benchmark results, so here. So the learning here is when we are adding function, it's not completely free. So in compiled language, it might be free because we'll have some inlining. And right now in Python, at least Python 3.13, it's not built in. We don't have the JIT yet, and not such optimizations. So adding a function might introduce some performance overhead when you're dealing with a lot of small operations. And so yeah, even if it makes the code easier to write, it can bring some performance pitfalls.
Yeah. Pretty quick example. Now we have a recursive function to calculate the factorial of an integer, and we have the same implementation but with a stack, which is faster. You'll have 10 seconds. Wow, dead even. But yeah, the stack factorial is faster by a bit. Yeah.
Yeah, so again, so here we have the benchmark result. And so again, we can do the disassembly. So here we have many more instructions, so we won't read everything. But the idea is pretty much the same. So here, pushing to a list is a built-in function, and popping to the stack as well is a built-in function. And those are not bringing any context switching, so we are not going to any other context, lambda function or anything. So in this case, not relying, it is pretty much the same, not relying on the context switching and having some multiple function called is interesting. And this pattern is often as well useful because sometimes you might hit the limit of recursive, the recursive call limit, basically created by the interpreter, because the stack cannot grow indefinitely. And so this pattern can actually save you, and in those cases, you'll be able to allocate memory somewhere else and be able to overpass this limit. So yeah, the learnings is mostly what we said.
It's like, recursive functions sometimes can be easier to implement, but they do come as, they do have a cost in terms of performance. Now, let's do something fun. You might have heard of Rust if you're doing Python, because a lot of Python libraries, a lot of Python code has been in the past and even still now rewritten in Rust, mostly to gain performance. We are going to do small experiments. We're going to use the Rust import library, which allows you to directly call Rust functions from your Python code. We'll start with this really simple example. On the right, you see we have a square pi function that just squares a number, and we have a square Rust function that calls the equivalent implementation in Rust. So again, which is faster? We have an input, an integer of 10,000.
And yeah, if you didn't heard about Rust import, it's a pretty cool library that allows you to basically start running Rust code directly from your Python code bases without bringing any heavy boilerplate, bringing cargo toml and a lot of stuff. So it's pretty handy to get started. Yeah.
Okay, most of you got it right. Yeah, Python is still faster, quite significantly. The idea is that here, for such a simple operation, we are going to pay an overhead because we are converting Python data, Python types to Rust types. So there is a cost to that, and in this case, the cost is not worth the switching to Rust. We are going to follow with another example, which is the Fibonacci function. Same thing as before, we have the Fibonacci, so it's an iterative Fibonacci. We have the Fibonacci pi on the right, which is in Python, and the same one in Rust on the left. We are going to use an input of 150, and this time, which one is faster?
And yeah, functionally, the code is exactly the same, computing the Fibonacci sequence. Okay, and yeah, you got it right as well. Rust is faster for this specific case as well, and mostly other cases, and it's actually really, really faster. So here, the biggest reason is that most of the code that is actually run is the native code. So in the previous example, most of the cost was basically switching off, context switching, here not directly in Python between functions, but to basically going from the native code written in Rust to the your Python code. But here, actually, since we have really a bigger workload that is run in Rust, it's really actually where it becomes really interesting.
Yeah, next example is going to be with binary search. So binary search is when we have a list of sorted integers, and we are trying to find an integer into that list. So we can do it with binary search. We can do it pretty fast. It's exactly the same implementation both in Rust and Python. We have 10,000 elements in sorted lists. So which is faster, Rust or Python? in that case, a lot of you got it right. Yeah, in that case, it's binary search in Python, and it's it's really astounding how fast, how much faster it is. The implementation in Rust is pretty bad compared to the one in Python. But why?
The reason here is actually a bit tricky. It's because mostly we need to transform the list, the Python list, to the Rust vec, so basically an array of unsigned integers on 64-bit. And this conversion cost is in linear time, so basically n, while actually the algorithm we are trying to optimize is in logarithmic time. So as the input grows, the cost of the Rust implementation actually increases more than the actual benefit we get from the algorithm. So this is why, in this specific case, Rust is slower, and basically transferring huge objects between native implementation and the CPython or Python code is actually really costly.
Yeah, but there is a silver lining. There is a good way to do it. Here, our algorithm was, we were transforming the whole list from Python types to Rust types, but we are actually only looking at logarithmic n number of integers. So instead of converting all of the integers, we are going to lazily convert the types of just the integers we are looking at. So this is the implementation on the right. Basically, the only thing that changes is the type of the list on the top. And we are only converting the integers lazily. And you can see that now with this new implementation, Rust becomes faster again because we are only converting the right amount of data. So the learnings about rewriting in Rust is that it's not a silver bullet. Like, you have to know what you are doing. You have to understand what you're doing. For small functions, built-in functions, it most often is not worth it. And also, you always have to think about what amount of data you're transferring from Rust to Python, and well, from Python to Rust and from Rust to Python, because there might be a huge overhead. Right. We have finished with the quizzes, so now we are going to see the leaderboard.
Suspense.
Okay, and so congratulations to Batus.
Congrats.
Who is it? Nice. Congrats. Congrats.
Good job.
No, it's okay. It's just to
Good job.
to see. But we do have a lot of stickers that
Yes.
we're going to give you.
So before we wrap up, since we don't have much more time, a few takeaways. So we saw that actually getting it right 100% of the time, okay, that was a tricky question, so maybe that was the reason as well. But getting it right 100% of the time is pretty hard. And thus measuring both memory consumption and as well execution time and profiling is pretty important to make sure that actually your guess actually matching the reality. And as well, it allows you to educate your intuition, because still it has a big benefit to have some intuition and performance. And so, yeah, don't forget to measure. And yeah, a quick announcement. So we released the performance chat. So basically, all those examples, we measured them with it. So it's basically like ChatGPT, but basically you can put some Python code and it will run them and help you benchmark and as well measure the performance data, give you profiling, compare libraries, and yeah. So yeah, we released this 1 week ago. So really excited. If you have some feedback and if you want to try it out, don't hesitate. It's free.
Thank you.
Thanks a lot.
Okay, so we have time for one quick question, and the question is regarding the for-some len question. Okay, did you check performance on different input sides?
The for-some.
Yeah.
I think
for-some len, one of the first, I think.
I will just take it. So it's not. So I guess it was this one. So the sum with one. I think we did try it on multiple size of input, and it doesn't really change because yeah, it's just the generator and the back and forth that actually contribute to the overhead. But this is something we could actually test in a minute with P99.
Testing that with different input sizes would be really, really easy with P99. We'll just tell it like test it with different inputs, and we'll have all the. It will automatically like generate the test cases. So, but yeah, we did test it with random sizes, and it always came approximately in that order. Yeah.
Okay. Thank you again.
Hello everyone. So we are going to start. First of all, I remember to you to go to the website to write your question on Slido. And at the end of the talk, if we have time, we answer some, and Gianluca answers some of them. So the next talk is from Gianluca about Django HTMX and a lot of interesting topic, and I'll let him present himself, but first give him a round of applause. Thank you.
So, thank you. I'm pretty excited today because it's my first talk in front of such a big audience, and in the end, after several years of attendee here at PyCon, is my first talk. So, please forgive me, especially because I will cough. It's turned out to be not to be a good idea to have a cold before a talk, but okay. So, my name is Gianluca Romani, and today we are going to flip things a little bit around, talking about backend first. And before starting, I would like to explain a little bit more who I am and where I come from. Only a question: how many of you know what an ARIC is? Please, hands up. Okay, nobody. Yeah, I was expecting this. Sorry. An ARIC, yes, it isn't the guy from the DevOps team, and not even a new Python package. ARIC is the Europe way of saying let's do science hard together, because in the end it stands for European Research Infrastructure Consortium. And is the way that Europe had to foster research in the last years. So currently there are about 32 ARICs in Europe, each one focusing in a specific sector. And I work for ARIC, which is a distributed research infrastructure consortium of of 8 countries and about 60 instruments, which are all focused on material science, biomaterial, or nanotechnology. So you can think of it like an Avenger-style alliance of research instruments, but instead of saving the world, we are analyzing materials with scary precision. So my background is a software engineer and technical manager. Currently, I'm working as a software architect and technical leader in ARIC on the proposal management system of ARIC. So if you are pretty curious about it, please check the website aric-aric.eu or just talk to me and my colleague Emiliano, which is something around. So what we are going to do today. So we are going to have a path from 0 to hero on the HTMX. There have been already a couple of talks on this in this PyCon, so no pressure on me. So there is a pretty old joke, and I want to ask you how many of you started a web development project in their career as a personal side project, for example, on static site generator, web library, hands up. Yeah, there is a joke telling that it's not a matter if, but just when a developer will start a web project. So I asked to ChatGPT to generate a couple of images, and it turned out to be wonderful, inventing some new names for your next web framework, like Angular, Flago, and Django and Rails. Yeah, because in the end, a lot of this project, or this personal project, became in the past big things. So, for example, Python in the 1991, PHP, JavaScript are big things for languages, but like Django framework, the first public release was in the 2K5, and then React, Angular. Finishing in the 2020 with HTMX. Just to have an idea, ChatGPT, the first really useful model was ChatGPT probably 3, was released on the late 2022, and it seems like dinosaurs today already. So I will have a couple of words on that, because in the end, if you are worried about ChatGPT stealing your job, like me, for example, so be positive and stay strong, because in the end the forecasts are not so well done. And okay, in the end, in the software, in the world, there have been already different kind of revolution changing the jobs landscape. So, for example, we still are talking about mathematician, tailors, and so on. So there will still be the need of software engineers in the future, maybe not so in the same way that today we are talking about, but okay. So leaving apart the jokes, a little bit of background of HTMX, looking at the GitHub stars diagram, you can see that HTMX is currently something very well established, like, for example, Vue.js, not the same as React, but we are there is a pretty steep curve, and it is a thing. So what is HTMX? It has been created by Carson Gross, which is a principal tech engineer at Big Sky Software, which is also the author of Intercooler.js, which is the parent of HTMX. So it is a minimalist JavaScript library, is about 14 kilobytes today. It extends HTML with new attributes to do something like AJAX request, WebSocket, and with some extensions, something more like server center events. If you are curious about the extensions, please check the web URL on the slide. I will give you the slide at the end of this talk. And why using HTMX? So ironically, the best JavaScript library might be the one that lets you avoid writing JavaScript, because you know JavaScript tends to be a little bit awkward sometimes. And I can tell you that HTMX is easier than explaining a closure to a product owner. So, okay, HTMX is not about removing JavaScript from your stack, but to enhance or reduce the amount of code spread all over in a mess. So it is simplify UI management and adds reactivity to your interfaces without using other front-end libraries. And it's perfect for server-side rendering. So I don't know if you know something about ThoughtWorks Technology Radar. It is a report released every 6 months, and it's a big thing to look about, to understand the future of the technologies. And HTMX was inserted in the 2023, while server-side UI in the 2022 as a technology to assess. So how does it work? HTMX extends HTML, adding new attributes to your tags. Like, for example, we can see hxGet, hxPost, which defines the URL to call with an AJAX request. hxTrigger, we specify the trigger event, or hxTarget, we specify the element of DOM to be swapped, and hxSwap, that defines the swap behavior. So in the end, a boring element like a div knows HTTP verbs in the end. So this is the diagram of the flow that you can have with the technology. Basically, the user interacts with an element of the page. HTMX captures the events and send a request to the server. So you can see the request on the right side of the slide. And in the end, the HTML fragment from the server is captured by the HTML JavaScript library and is swapped in the DOM in the specified target with the specified swap behavior. So in the end, HTML is building your page just in time with little requests, one step at a time, swapping the little parts of HTML and adding that to your web page. So a couple of words on a little bit of philosophy. I mean, this is a screenshot of a blog post of Carson Gross talking about locality of behavior. I think it was probably in the 1990s when Richard Gabriel, which is the author of Worse is Better, introduced the concept of locality of behavior. Richard Hickey, which is the author of the closure language, enhanced the concept of the overhead of scattered code. So there is also a wonderful talk of Alex Martelli cited yesterday by himself, speaking about the concept of principle of good enough, the right thing, worse is better, and so Richard Gabriel and a lot of other amenities that every developer should know. So take a look. It was EuroPython 2013, and I was here, so I'm pretty old. So Loeb tells that the behavior of a unit of code should be as obvious as possible only by looking at that unit of code. So Loeb is about keeping your behavior close to your markup. So for example, like at a good pizza, everything on a slice. And okay, is somewhat conflicting sometimes with other concepts like don't repeat yourself or separation of concept, but in the end, experience for a software engineer is about making some trade-offs and understand when to apply or not a thing, because, for example, sometimes separation of concern just means harder to debug. So just to understand a little bit the approach, this is a little example coming from the documentation of HTMX. So on the top part of the slide, you can see that the implementation of the AJAX request of the click, and it is a single line. It's pretty simple. On the bottom side, there is the implementation of the jQuery thing. So one part for the JavaScript file, one part for the markup. It is a stupid example, but it makes the point, in my opinion. So how to add HTMX in Django? Adding HTMX to Django is easier than explain a thing to a project manager in the end. So it's really easy. You can add it by using a manual approach, linking the script by yourself, or I suggest to use the Django HTMX add-on of Adam Johnson, which is the author of several books, which is very well established. In the end, it's just adding the app to your installed app in your Django settings, and optionally the middleware. We will speak about that in the next slides. And on the right side, in the bottom right side of the slide, you can see the Django main template, where we are loading the tags, we are putting the HTMX script tags and the HX header, which is important because the Django itself is checking for security the CSRF token. Okay. So a simple example. This is pretty stupid. Just a couple of views on the top left, just a routing on the bottom left, and the template on the right side. You can see the same pattern that I showed before for the HTMX installation. Basically, we are adding a name and swapping with a form and swapping the content of the fragment returned by the greet view in the response div. So there is a div on the right side which is which have the id response. Just to understand a little bit more, there is a video about it. So for example, adding the name and swapping the content. And you can see on the left side the logs of the web server. So it's easier also to debug. A more complex example. So we'll leave apart the user experience questions for the moment. We are dealing with a proposal of some researcher. He is asking for some instruments, and in each instrument, he wants to bring its own samples of materials. So he should specify the samples. This is the screenshot of the page. So you can see the blue button, which is the one that it's opening a model, and on a model we will call different kind of sections of our backend, changing the content with HTMX calls. So we are using a model admin class, basically an inline model admin de facto in the change form, and the idea is to add some field method, so an arbitrary method used as a field to inject the button with a model in a table, so the blue button. We can see the video of this. So clicking the button, opening the model, In the model, there is another section. In this section, we can view a sample, modify a sample, which is pretty complex also, go back, delete the sample, cancel or add a new sample, and going back, being on the same page. So we are using a Bootstrap model and standard model admin. A lot of Django developers prefer to develop their own views to do something like an admin portal, but in the end you should notice that the model admin class of Django is already the 90% of what you need, because it's implementing a lot of things like the basic crude views, but also the permission management. For example, you can have the change list view, which is the list of all your model instances, and in that page you have also the filtering, you have the paging already are coded by the framework itself, and the change form add change a model instance, or the delete form to delete an instance. So it's pretty useful and completely customizable by the user, by the developer, sorry. In this slide, you can see also the sample description admin class, that manages all the samples related to an instrument usage. It is the one loaded in the model, the content loaded in a model, and you can see also the field method, which is substance underscore view underscore link, which injects a little bit of HTML with the HTMX attribute. So you can see the HX get, the HX target, which is the modal body of the Bootstrap model, the swap behavior, and the trigger, which is the click, basically. So a couple of words also on the hosting code. So the one with the blue button, for example, it is injected with another field method. I used, for this example, the Django rendering engine, which renders the template specified here. And on the right side, you can see the template. You can see the blue button, which is the button element, and the modal underneath. So, by using this trick, we can open a model and use a standard model admin class in that model. In this way, we are using the basic views of the model admin with some customization to render as a fragment, because in the end, we don't need something like the sidebars, headers, CSS, JavaScript, and so on, because we are looking for the content inside the model. However, with the HTMX middleware, you can see on the right side the official documentation of the middleware. We can manage to have in the same URL two different behaviors, so loading the full page or the fragment partial. You can see that the HTMX middleware will add an attribute to your request to understand what kind of request is. And for example, in this example, you can see also a couple of other decorators used to manage the cache of Django. I never had some issues with the cache of Django, but if you have some issues, you can rely on the very own decorator or the cache control decorator. So, how does this simplify the state management? So, first of all, no client-side state. So we are avoiding complex stores like Redux, Vuex, and context cell at all. So, amen. We are keeping the logic on the back end, so which is easier to debug. The HTML is the main source of truth. So you can use the Django logs to understand what happens, for example, and we avoid the duplication between front end and back end. A couple of words on performances. We are talking about quantitative and subjective performances, no benchmark. However, we can say that in the average, the traditional way of working, so standard HTML or single-page application, is lighter on the responses because usually you use some kind of data protocol like JSON, but there will be a lot more requests to build the page, and the client load will be higher, while the server load will be lower. It will be the right opposite with HTMX, because we are serving HTML. but the number of requests will be lower. So when to use it? If you have only static content and minimal or no interactivity, and the standard HTML is enough for you. If you need some reactivity on your pages, try server-driven UI first, because in the end you avoid a lot of complexity, so the JavaScript will be simpler. And okay, if you have to deal with some trade-offs, for example, we are all full-stack developers, and it will be difficult to have a front-end developer in the team to hire someone. HTMX is the technology for you. But if you have to deal with highly dynamic real-time apps, probably a single-page application is the right choice, because also if you have some kind of mobile app that should handle also the offline behavior, HTMX is not for you, because you always need a server online. So we can say start with HTML, add HTMX when needed, and if this is not enough, go also for single-page application framework. But if you have any problem, okay, you have to solve some JavaScript spaghetti code. Okay, so HTMX is a very zen and simple technology, avoiding a lot of complexity, and in the end, nothing more than that. But I want to add some bonus content, because in the end, I know that is quite easy today to ask to ChatGPT and Stack Overflow, but in the end, the documentation of HTMX is really, really good to the target, so take a look. For example, there is a quietly very, very documented integration with side technologies for HTML, like CSS. And this is an example coming from the documentation. For example, you can apply some CSS animation on the swap behavior, maybe fade out, fade in, like it is shown in this slide. And for example, there is the hxOn attribute, which extends the onEvent property of HTML. Usually, it's available for few elements and a very limited amount of events, basically only the click. On the bottom side of this slide, you can see that we are mapping 2 events to trigger some alerts. hxOn extend the generalized mechanism for responding to arbitrary events on all the elements. So a more complex example of this comes from our code base. For example, we integrated a React web component in a Django tabular inline. Yes, you can mix React, Django, and HTMX. Yeah, you have to stay calm to do that. Okay, but we avoid the spreading of additional files here and there just to load the component and match the workflow. So we can see that on the form field for DB field event, when the DB field is built, we are adding the HTMX attributes to have a get, a trigger, and to map 2 events that call the web component JavaScript, a couple of functions to match the workload. And we use also the hx params and hx vals, which are 2 different attributes. The params allow us to filter out the parameters passed to the AJAX event, while the vals allow us to transform and add values passed to the AJAX request. Another bonus is response headers. So, for example, we have the capability of handling the response header on the HTMX partial response. We can change the behavior of the client, customizing the headers. For example, on the left side, you can see the redirect of the client or the full refresh of the page. On the right side, you can see a definition coming from the official documentation of the headers that you can handle. And there is also hx trigger, which is useful if you want to trigger some specific JavaScript event, on the response of your partial. And that's all. A couple of final notes. You can connect with me via LinkedIn. On the right side, you can see the QR code, and you can download all the material on the left side. Just a suggestion, don't let friend over-engineer the front ends. So that's all from me.
Thank you. It's working. Thank you, Gianluca. At the end it worked. So thanks a lot. It was very interesting. Yeah, I remember to you, if you want to ask for a question, you can use Slido. And at the moment there is no question, but I have one. So the most famous recording on the DjangoCon YouTube channel is about a talk from the transition to a very highly dynamic website in React, translated in Django and HTMX, and it's very interesting. And would you suggest some other resources apart from the official documentation that maybe helped you to study HTMX, article, video, or some?
Well, I
content?
find useful a lot the blog of Carson Gross, because usually it explains also the architectural decisions to implement HTMX. But in the end, the official documentation is enough. I suggest also to check other side technologies like Alpine.js, which has a really similar philosophy, because it's a matter of philosophy in the end. So it extends the attributes. So usually a lot of HTMX users usually include also Alpine.js.
Okay, thank you. If there is no question, I think we can thanks again, Gianluca, and give you another applause.
Si sente? Sì.
Prova. Ok.
Sì, in italiano.
Benvenuti a tutti. Ok, allora innanzitutto vi ricordo che c'è Slido per fare le domande, lo trovate sulla pagina del sito del talk, e alla fine faremo una sessione di Q&A con Lisa. Ok, quindi partiamo con il talk di Lisa. Lisa è un membro dello staff di Python Pescara, vi dirà due cose lei della sua carriera, perché è qui. Però facciamole prima un grande applauso.
Ciao a tutti, io mi chiamo Lisa Di Marco, studio medicina e ho deciso di imparare Python principalmente per una curiosità personale ed oggi vi spiegherò come l'ho imparato io, vi spiegherò tutta una serie di step che ho applicato io sulla base di quello che ho appreso durante il mio percorso di studi in medicina per quelli che sono i metodi che io reputo migliori e vi dirò anche perché questi metodi sono migliori da un punto di vista neurofisiologico. Iniziamo subito con il primo step, che è quello di scegliere un'area di interesse. Identificare l'area di interesse significa scegliere un'area che sia sviluppo web piuttosto che data analytics o machine learning. Questo ancora prima di iniziare a studiare, in modo tale da non disperdere l'energia e stabilire subito un obiettivo concreto. Questo ci permette di fare una ricerca attenta e selezionare le librerie pertinenti a quello che è il nostro obiettivo. Definizione di obiettivi concreti e raggiungibili significa stabilire un tempo entro il quale portare avanti questo studio e pianificare il percorso di apprendimento creando una roadmap mirata. Quindi andremo a suddividere il tutto in micro step per ricalibrare gli obiettivi in base ai progressi e agli imprevisti, utilizzando risorse specifiche per la nostra area, quindi andando a selezionare da prima ancora di iniziare il materiale che preferiamo, sia esso un libro piuttosto che un tutorial, piuttosto che un videocorso. Chiaramente se normalmente ci troviamo meglio con i libri è meglio rimanere focalizzati sull'utilizzo di un libro di testo piuttosto che andare a scegliere un tutorial che magari inizialmente può essere dispersivo e può comportare una certa fatica all'inizio. Perché ricordiamo meglio ciò che ci appassiona? Prima abbiamo detto che fondamentalmente nel momento in cui andiamo a scegliere un'area di interesse dobbiamo scegliere anche qualcosa che ci piaccia. Questo perché le emozioni potenziano i processi di memorizzazione del cervello e facilitano il trasferimento delle informazioni dalla memoria a breve termine a quella a lungo termine. Perché quando c'è un'emozione di mezzo nello studio si attiva anche l'amigdala, che è una parte del sistema limbico, ovvero la parte più atavica e primordiale del cervello, che è in correlazione anche con l'ippocampo, che è la parte del cervello deputata al trasferimento delle informazioni dalla memoria a breve termine a quella a lungo termine. Inoltre c'è anche un rilascio di dopamina da parte dell'area tegmentale ventrale, che fa sempre parte del circuito mesolimbico, ovvero il circuito di reward. Come funziona? Quando uno stimolo è gratificante, i neuroni dell'area tegmentale ventrale, che sono quelli appunto che rilasciano dopamina, li rilasciano nel nucleo accumbens, ma anche nell'area prefrontale, oltre che nell'amigdala. Questo rinforza il comportamento, aumentando la probabilità che venga ripetuto. E infine la corteccia prefrontale aiuta a valutare se vale la pena ripetere l'azione, perché la corteccia prefrontale è quella deputata alla pianificazione e alla decisione. Terzo step, imparare bene i tipi di variabili. Questo è fondamentale perché ogni tipologia di variabile ha delle sue funzioni e ha delle sue specificità. Quindi andando a selezionare il tipo di variabile corretta ci permette di andare ad applicare anche le funzioni corrette in funzione di quello che dobbiamo fare. Step numero 4, approccio pragmatico allo studio. Io qui propongo due tipologie di approcci allo studio. Il primo è un approccio un po' più strutturato, in cui andiamo ad imparare una libreria o un concetto alla volta, ed è ideale per chi preferisce una comprensione più approfondita e strutturata. Banalmente, attraverso questo metodo andremo a studiarci una libreria per intero e poi ad applicare i concetti uno alla volta. A differenza dell'approccio project-based, che invece prevede di imparare soltanto quello che è necessario per completare il nostro progetto, ed è un approccio più pratico, che ci permette subito di portare a termine qualcosa e quindi potremmo avere un riscontro dei risultati più immediati rispetto all'approccio precedente, che può essere più sistematico e macchinoso. Scomporre le librerie in moduli funzionali. Anziché cercare di padroneggiare un concetto tutto in una volta, la cosa migliore da fare, secondo me, è quello di suddividerla in micro aree basate su task pratici, andando ad imparare una funzionalità per volta. Quindi prendiamo l'esempio Pandas. C'è una sezione che ci permette di andare a lavorare con i CSV, quindi quello che consiglio di fare è di imparare prima questo, poi partire alla gestione poi andare alla gestione delle tabelle e così via. Quindi andare a dividere le librerie per tutte le funzioni che una libreria appunto può fare. Jupyter Notebook lo trovo particolarmente utile per questo, perché ci permette appunto di testare singoli blocchi di codice in isolamento. Il chunking è fondamentalmente il concetto che vi ho appena espresso, ed è la vera e propria suddivisione di un concetto in blocchi per facilitare la memorizzazione e il recupero. Questo ci permette di ridurre il sovraccarico cognitivo, facilitare la memorizzazione, ma anche migliorare la comprensione. Prima di tutto avremo un'esposizione iniziale e una comprensione globale, quindi andremo ad approcciare la libreria per intero, andando a capire bene che cosa fa, andando appunto poi a fare quello che dicevamo prima, quindi a spezzettare in unità funzionali. Ogni mini chunk deve essere appreso ed interiorizzato separatamente fino a renderlo automatico. Questo significa che prima ancora di iniziare ad unire tutte quelle che sono le funzionalità è meglio apprenderle prima singolarmente e poi soltanto una volta che sono state fatte tutte andare ad unire quello che si è appreso. Che una volta assimilate le unità più semplici si passa subito diventa più facile poi andarle a riunire tra di loro. Perché si impara meglio attraverso la comprensione rispetto alla memorizzazione. Quando capiamo un concetto, fondamentalmente rispetto alla memorizzazione, innanzitutto attiviamo molto di più la corteccia prefrontale rispetto ad altre aree che sono, come dicevamo prima, l'ippocampo, ma anche la corteccia temporale mediale. Il potenziamento a lungo termine è più robusto e andando a comprendere un concetto lo riusciamo a collegare a delle reti neurali già esistenti nel nostro cervello. Fase 6, apprendimento pratico. Vi avranno già detto tutti che è fondamentale fare tanta pratica per apprendere bene il codice. La prima fase, secondo me, è quella di andare a modificare del codice esistente. Quindi andando a lavorare su codice già scritto, quindi magari seguiamo un tutorial, seguiamo qualcosa che già esiste, andando a leggere e comprendere e poi apportando delle modifiche molto piccole a quello che è quel codice già esistente. Questo ci permette di chiederci che cosa sta succedendo, perché la persona sta facendo questo e quindi ci permette una migliore comprensione di quello che sta succedendo. Fase 2, ricreare progetti semplici da zero. In questa fase andremo ad apportare delle modifiche a quello che era il nostro progetto già fatto, quindi quello che avevamo fatto prima, seguendo il tutorial, andiamo adesso a modificarlo in funzione di un qualcosa che ci interessa o che vogliamo portare a termine. Fase 3, questo è il momento in cui iniziamo effettivamente a farlo da soli, quindi iniziamo a pensare ad un problema o ad un'idea da realizzare, progettiamo e implementiamo la soluzione e poi integriamo sempre di più degli strumenti avanzati man mano che procediamo con l'apprendimento. La pratica è importante. questo ve l'avranno già detto tutti, ma perché la pratica è così fondamentale? Fondamentalmente perché ci permette di andare a consolidare quelle che sono le connessioni neurali che dicevamo prima. Quindi migliora la ritenzione delle informazioni e l'apprendimento risulta molto più efficace. In questo grafico, non so se vedete il cursore, sì. In questo grafico vi mostro la cosiddetta curva dell'oblio. Fondamentalmente, se noi andiamo a separare tra di loro delle sezioni di pratica, che sono quelle indicate dalle frecce, separate da degli intervalli di tempo sempre più lunghi ma allo stesso tempo regolari, andiamo a rafforzare quelle che sono le connessioni neurali che vi dicevo prima e andare a contrastare la curva dell'oblio, che è questa. Quindi in questa sessione di ripasso di quello che è stato fatto si vanno a consolidare le reti neurali. Questo perché il meccanismo che sottende la curva dell'oblio è la plasticità sinaptica. La neuroplasticità è una caratteristica del sistema nervoso centrale che consente di creare nuove sinapsi tra neuroni non collegati precedentemente, rafforzare le connessioni esistenti attraverso l'uso ripetuto ed eliminare sinapsi inutilizzate, il pruning sinaptico, per ottimizzare le risorse. Il pruning sinaptico è un qualcosa che è fortemente attivo durante l'adolescenza, in modo particolare, perché durante l'infanzia è particolarmente attiva invece il potenziamento a lungo termine, che è un fenomeno in cui fondamentalmente il numero di sinapsi aumenta, perché come sappiamo durante l'infanzia c'è una maggiore predisposizione all'apprendimento, mentre invece durante l'adolescenza quello che non è stato utilizzato viene potato e il cervello si sviluppa in modo più efficace. Questa è una sinapsi. Il neurone, questo blu scuro, è il neurone presinaptico, mentre il neurone, questo blu celeste, è il neurone postsinaptico. Questo è il funzionamento di una sinapsi fondamentalmente. Queste palline qui sono delle vescicole, queste strutture qui invece sono i recettori. Dal neurone presinaptico emergono delle vescicole contenenti una molecola chiamata neurotrasmettitore. Il neurotrasmettitore viene rilasciato qui, che è lo spazio sinaptico, e viene captato dal recettore e succede un qualcosa nella cellula postsinaptica, che può essere lo scatenarsi di un potenziale d'azione piuttosto che un'inibizione. La legge di Hebb assume che quando un assone della cellula A, presumibilmente quella presinaptica, prende parte ripetutamente o persistentemente all'attivazione della cellula B, ovvero quella postsinaptica, si verifica un aumento dell'efficacia con cui A stimola B. Tradotto in parole povere, questa è la legge che sottende la plasticità a lungo termine, ovvero un meccanismo attraverso il quale, andando a stimolare maggiormente una cellula postsinaptica, cioè la stimolazione ripetuta della cellula postsinaptica da parte della cellula presinaptica ne favorisce ancora di più la stimolazione. Fondamentalmente la cellula, vi faccio vedere l'immagine, la cellula presinaptica normalmente rilascia neurotrasmettitori, in questo caso rilascia glutammato, e i recettori, questi sono dei recettori NDMA, captano il glutammato e viene innescato un potenziale d'azione nella cellula postsinaptica. In caso di potenziamento a lungo termine, invece, il neurotrasmettitore rilasciato, quindi il glutammato, viene captato dai recettori NDMA sulla cellula postsinaptica, che inducono anche l'ingresso di ioni calcio. Questi ingresso di ioni calcio inducono una trasduzione del segnale, tale per cui poi nel nucleo si attiva la trascrizione di geni deputati ai recettori AMPA. Questa amplificazione dei recettori permette ad una successiva stimolazione di avere più recettori disponibili per il glutammato e quindi una maggiore stimolazione della cellula con una minor quantità di glutammato. In altre parole, a parità di glutammato, la cellula postsinaptica viene stimolata maggiormente. Fasi della memoria. Inizialmente c'è una fase di codifica in cui iniziano a formarsi le tracce amnestiche, quindi è una fase precoce del potenziamento a lungo termine, mentre il potenziamento a lungo termine tardivo prevede una fase di consolidamento in cui queste tracce vengono stabilizzate e poi, come dicevamo prima, nel momento in cui si va a stimolare nuovamente dopo un certo periodo di tempo c'è la fase di recupero, in cui c'è un vero e proprio accesso alle informazioni memorizzate. La memoria esplicita è quella che viene coinvolta nel momento in cui approcciamo per la prima volta un concetto. Quindi, ad esempio, se dobbiamo memorizzare la sintassi, interviene principalmente la corteccia prefrontale, che deve sforzarsi, diciamo, per comprendere teoricamente quello che sta succedendo, per apprendere le librerie e poi la corteccia prefrontale comunica con l'ippocampo, con la corteccia temporale mediale e, come dicevamo prima, eventualmente anche con l'amigdala, per andare a creare questi circuiti neuronali che saranno quelli deputati a farci comprendere un determinato concetto di programmazione. A differenza della memoria implicita, che invece è quella che subentra quando un concetto è già stato assimilato, quindi diventa più automatico, infatti è coinvolta nei processi di automatizzazione che sono per lo più inconsci. Le strutture cerebrali coinvolte sono diverse, sono i gangli della base, il cervelletto, per quanto riguarda l'apprendimento motorio c'è anche la corteccia motoria e quella sensoriale. Quindi, come dicevamo prima, sussiste inizialmente un'esposizione iniziale e attraverso la pratica ripetuta si giunge ad una condizione di automatizzazione. Step numero 7, approccio graduale. Io qui consiglio due tipi di approcci alla programmazione, che sono quello top-down, che prevede il partire direttamente da un progetto, scomporlo in vari sottoproblemi funzionali. In questo modo andremo ad imparare direttamente mettendo le mani in pasta, quindi attraverso l'applicazione di quelli che sono i concetti che ci servono per portare a termine il progetto. Ci permette di avere una maggiore motivazione perché vediamo dei risultati tangibili. Di contro rischiamo di avere un apprendimento un po' più superficiale e privo di basi effettivamente solide. C'è anche un approccio bottom-up che invece prevede di partire dalle basi, studiando prima tutto, costruendo conoscenze fondamentali, quindi facendo vari esercizi, consolidando le competenze prima di affrontare i progetti grandi, solo che questo modo di fare è un po' più lento e può risultare meno motivante. Errori da evitare. Il primo errore da evitare sicuramente è quello di studiare Python come se fosse una materia universitaria, approcciandola in modo troppo teorico, quindi evitare assolutamente la memorizzazione e un apprendimento passivo. Python è un linguaggio di programmazione talmente vasto che la prima cosa da fare è quello di cercare di comprenderlo il più possibile. Superare la frustrazione iniziale. In un primo momento può avere una curva di apprendimento piuttosto rigida, quindi meglio cercare di mettersi nell'ottica che bisogna imparare molto bene la logica e il tipo di ragionamento che c'è sotto e poi si riusciranno ad avere dei risultati. Errore 3, il blocco del modo giusto di fare le cose. Essendo un linguaggio di programmazione, appunto come dicevamo prima, molto vasto, ci sono vari modi per fare le cose, quindi cercare ossessivamente il modo perfetto, la soluzione ottimale prima di agire ci può anche far perdere tempo. Quindi sempre meglio sperimentare e vedere un po' che cosa succede. Finito, grazie per l'attenzione.
Grazie Elisa, è sempre molto interessante capire come funziona il nostro cervello quando facciamo quello che ci piace fare, cioè usare Python. E andiamo a vedere se c'è qualche domanda, se volete potete usare Slido, al momento non le vedo. C'è qualcuno che ne ha messa qualcuna? No, c'è qualcuno che la vuole fare? Ok, vabbè, tanto siamo pochi.
Sì. Faccio la domanda qui? No, perché è corta, poi perché le università lo fanno ancora in modo teoretico? Dopo un po' di background, mia moglie ha appena cominciato a fare uno studio e adesso ricominciato a studiare, ha fatto anche un corso, sta facendo un corso di Python per linguisti, e Però adesso è disperata perché ha fatto tipo, ieri ha fatto regex e lei ha detto no, io smetto. Perché lo fanno ancora? Non fanno come dici te?
No, questo non lo so, bisogna chiedere a loro, credo.
C'è qualche insegnante universitario in sala? No, ok, se no potevamo chiedere. Qualche altra domanda, curiosità? Hai scritto? Ok. Sì. Ok. Allora, hai esperienze di altre persone che hanno imparato Python come te?
In realtà no, è un modo che ho sviluppato io dopo che ho studiato per tanti anni medicina e quindi ho appurato che gli stessi metodi che funzionano per medicina funzionano anche per l'apprendimento di linguaggi di programmazione. Diciamo che io sono abbastanza precisina per queste cose.
Abbiamo intuito. Altre curiosità, domande?
Salve, volevo chiedere se suggerisci quando si inizia a imparare il linguaggio Python comunque partire da arrivare almeno al punto di conoscere la sintassi, arrivare almeno alla programmazione ad oggetti, visto che non è una cosa talmente scontata per i neofiti, oppure visto che siamo un po' stimolati da quello che ci piace, tanto vale lanciarsi allo scaricamento della libreria e imparare la libreria, però anche rinunciando a parti di sintassi avanzata di Python, programmazione ad oggetti, metaclassi.
Allora, io personalmente ho imparato prima, sono arrivata ad imparare la parte di programmazione ad oggetti e poi sono passata alle librerie, quindi per quella che è la mia esperienza consiglierei anche di farla questa parte prima di approcciare librerie vere e proprie, perché può sempre tornare utile in qualsiasi momento. Sapere anche la programmazione ad oggetti, per esempio, a me piace la parte di data analytics e mi sono trovata magari in un paio di progetti a doverla utilizzare, la parte di programmazione ad oggetti, quindi sempre meglio saperla. A prescindere poi dalla diramazione che si prende, almeno la sintassi di base è una buona cosa da sapere.
Grazie.
Grazie Lisa intanto. E ti voglio domandare, questi step sono applicabili a persone di tutte le età? Cioè, mia mamma mi ha domandato se, ora che è in pensione, se posso insegnarle Python. Dico, ma posso insegnare a un cane che ha tanti anni un nuovo trucco?
In che senso?
Cioè, nel senso, il cervello è ancora tanto plastico. No, dai, no, senza offesa. Mentre lo dicevo mi sono un po'... Cioè, il cervello comunque rimane tanto plastico da poter imparare anche quando si è anziani?
Allora sì, tendenzialmente sì, chiaramente la plasticità sinaptica tende a decrescere un po' con l'età, però in realtà comunque un certo margine di flessibilità c'è, quindi sì, si può imparare a qualunque età, qualsiasi cosa.
Grazie. Altre domande? Sei sicuro?
Quando esce il tuo libro Come imparare Python?
Domani.
Io ho una curiosità in realtà, forse non mi ha chiesto, ma hai aiutato qualche collega di medicina a imparare Python, a studiarlo usando i tuoi consigli che ci hai appena dato?
No.
O nessuno si è imbarcato?
No, nessuno si è incuriosito.
Ah, ok, va bene. Allora poi quando uscirà il libro...
Lo divulghiamo.
Va bene. No, è molto veloce. Sì, però non ti sento poi.
Perché Python poi?
In che senso?
Perché Python come linguaggio?
Perché l'ho trovato più interessante rispetto ad altri, perché ha una moltitudine di applicazioni che personalmente ricalcano quelli che sono i miei interessi in ambito informatico, quindi comunque quella che è la mia curiosità in questo settore, quindi ho scelto questo.
Grazie. Sembra che siamo un po' timidi, quindi escono un po' gradualmente, quindi aspetto un attimo.
No, ti interessa anche di Python, ti interessa soprattutto il linguaggio oppure anche tipo l'automatizzazione? Perché, lo chiedo perché penso che l'abbiamo visto che imparare un linguaggio non è facile come diciamo 20 anni fa, ai giovani come facciamo a imparare? Io mi mettevo lì a scrivere a 2 righe, print e qualcosa e così andavo avanti, ma oggi devi anche fare la parte DevOps per deployare un'applicazione. Lo trovi difficile? Imbarcheresti in questo viaggio? Lo vedi anche per altra gente?
Non ho capito bene il punto della domanda.
Penso che imparare un linguaggio di Python è molto una cosa limitata anche per, sì, se lo vuoi, se sei motivata.
Ah sì, certo.
Sì, però se vuoi deployare il tuo software magari rinunceresti, chiederesti uno che lo sa fare o ti butteresti in questa avventura?
Ma io imparerei qualunque cosa, quindi...
Sì, allora sì, si applica a tutto.
Grazie Peter. Ok, abbiamo ancora 30 secondi, se c'è un'ultima curiosità, altrimenti direi di fare un altro applauso. Ah ok, vedi, allo scadere.
Sì, una domanda che non può mancare, gli LLM aiutano o sono peggio perché danno una risposta pronta e uno rischia magari di applicare la risposta e non cercare di entrare nel meglio? Voglio fare qualcosa, chiedo, mi dà il pezzetto, lo butto dentro, funziona e ho risolto.
Allora, secondo me sono buoni più che altro per un confronto. Diciamo che magari possono essere utili per il debugging, per capire che cosa non è andato nel tuo codice, oppure per magari non ti ricordi una funzione, lo chiedi direttamente all'intelligenza artificiale e ti risponde. Più che altro per quella che è la mia esperienza li ho dovuti utilizzare perché non avendo un confronto con delle persone, avendo imparato da sola, da autodidatta, diciamo che farmi fare il debugging dall'intelligenza artificiale mi è stato utile perché ho avuto modo di capire dove stavo sbagliando, perché non funzionava e lui poi me lo spiegava, mi spiegava gli errori e mi dava anche un'opzione migliore rispetto alla mia, poi chiaramente sta sempre a me decidere se applicarlo oppure no, o se provare altre strategie oppure no. Quindi in generale io direi di sì, ma con raziocinio.
Grazie. Allora, un ultimo applauso. Grazie. Tra poco ci sarà il prossimo talk, quindi a tra poco.
Well, welcome everyone. Thank you for being here. This is Enjoying Building GraphQL Web APIs with Jonathan. And if you want to ask any questions, you can use Slido. On the site, if you do /Slido, you can go directly there. And you can type your questions. You can vote for the ones that are already asked, and they will have priority. And we will have the Q&A at the end. So the floor is yours, Jonathan. Thank you.
Test. Oh, it works. OK, thank you. Yeah, so everyone who wanted to go to the lightning talks, but the room is full. This is essentially a lightning talk, but it's 45 minutes, as in I'm not really prepared. OK, I am prepared, but I got notified that someone couldn't make it to the conference, and there is space to do a talk, and I was asked the day before I came here, and now you and we know as much about this talk as everyone does. I don't know what I'm going to talk about, but I have slides at least, so that's going to be fun. Yeah, that's me. Actually, that's a QR code. That's not me. I'm here, but that's the QR code that is on my badge in case you're curious to see another picture of me where I'm holding a cute dog. It's not my dog. I stole it from my sister, but it's there, and you can look at it in case the talk gets too boring. Yeah, my name is Jonathan. I'm technically a CS student at a German university called Karlsruhe Institute of Technology. It's KIT. It's kind of like MIT, but for poor people. But it's nice. And I'm a research assistant there at a research institute that is concerned with accessibility of digital documents. It sounds super boring, but there's people who need assistance, like during exams or just studying, and we make that possible with a lot of AI and with a big document remediation platform. That's how we call it. The point is I'm using GraphQL, the technology, in that project, so I know a lot about it from that context. But technically, I'm also, I guess, CEO, CTO, everything at another company. It's a startup I founded 5 years ago. It's a free game server hosting company. We use GraphQL as well, a lot actually. So in case the talk gets too boring, you can play on a free Minecraft server and technically still use GraphQL and enjoy it. So that's an option too. But yeah, point again is I use Strawberry GraphQL in that context a lot as well. And there's another reason I'm actually one of the developers of Strawberry GraphQL. So is he. He's actually the author of the whole thingy. And there's a previous developer. No, not you, not the previous one. That would be horrible. He's an active one. But there's a bunch of people in the room. So if there's spicy questions at the end, I think we can handle it. And maybe not me, but them. Yeah, I'm actually going to talk a lot about the parts of Strawberry GraphQL in this talk I'm most familiar with. That's why it says something with web APIs, because that's the area I'm most active in. You can use GraphQL for a lot of cool things, like internal APIs. You don't have to surf them over the internet. You can do really weird stuff, like put GraphQL in front of your file system and then, I don't know, have fun, enjoy it. That's kind of the point of all of this. OK, let's see. Oh, my notes said I should mention that I'm a Strawberry GraphQL developer and that these slides might be biased towards this framework versus our competition. But there's not really any competition, right, Patrick? They're all code of conduct. OK. OK, what's this Strawberry one is talking about? Like, not just me, like everyone at the conference, like you heard it a lot, right? Well, it's a cool library, but we actually want to talk about not just any library, but a library that's enjoyable to use, right? So what does make a library enjoyable to use? That's my definition, like what makes it enjoyable for me. It must be a library that does the job, otherwise I would not pick it, right? It's not fun to use an unrelated library to your problem, then you're not going to solve the problem. It should be well maintained. For various reasons. One of them is at some point you will realize it actually does not do the job. And if it's well maintained, you can ask someone to help you with your problem to like fix something in the library, or you get your own changes merged into the library. That's kind of how I ended up here, because I needed a lot of stuff that Strawberry couldn't do yet, and now it can. And since it was so well maintained, that was actually a lot of fun to do. I will advertise that a bit more later. It should be fun to use. That can mean a lot of things. It's mostly, it has a nice syntax, I guess, or nice patterns. It uses modern language features. It doesn't stand in my way. It's just fun. And it should be fun to test, because if we want to use it in production and testing is not fun, then I'm not confident shipping it, or I shouldn't be confident shipping it. So if it's not fun to test, I'm probably not going to enjoy that library all the way through. And I would definitely not enjoy coming back to a project that uses it a few years later and then realize it's broken because I couldn't test it. And yeah, optionally, it should have the Strawberry GraphQL logo, but there's alternatives, but not in this talk. Okay, so as I said, what's that Strawberry GraphQL everyone is talking about? It's a library for GraphQL, which is a protocol, and we implement it. Actually, we implement the server side of things, so it's not a client library you could use to like interact with other GraphQL servers. It's to make servers. And it has an immense focus on developer experience. That's why it's so fun to use. And we know that's a trade-off, but I think we're really good at it. Or at least Patrick was really good at it, and we just copy what he did. And then we always think about what would Patrick do, and yeah. So it uses type hints everywhere, so you get a lot of autocompletion in your IDE, which is awesome. We have support for like modern language features, not that modern anymore, but we support asynchronous functions and stuff like that. We have a command line interface that can be used for code generation, so you can get started quickly. We will take a look at this later. And we have code mods, like if we do an upgrade of Strawberry that has some breaking changes, and it's a pattern we can easily like recognize, then we write a code mod for it that will automatically upgrade your code for you when you upgrade to the next Strawberry version, so you don't have to fix all the stuff yourself. You just call a command. We have super cool errors, like that's the good kind of errors. It's an error that actually tells you what is happening where and how to fix it. So it has a link to our documentation. You just click it and do whatever it says, and you will understand why did it break and how can I fix it. Yeah, we have a super cool syntax, and we have many batteries included. Some of them are on the right side. There are certain problems that are common to GraphQL in general, and we have solutions for them, something called data loaders or federation and stuff like that. If you don't know about it, you will learn about it eventually. We have it, and it's first party, it's tested, and yeah, you don't need an extra package or do it your own. Yeah, speaking of being well integrated, we are also integrated with your favorite web frameworks, probably. Like there's a bunch of them, so if you're a normal web developer, like on the server side, I guess, so I guess a backend developer, and you already have your favorite backend framework like FastAPI or Django or something, then we probably have an integration for that already, and you can, well, just reply what you already know about your favorite framework, and Strawberry will integrate with it. Who uses Strawberry? I always like that. Whenever I pick up a new library, I check who is actually using it. Like, is it so niche no one has ever used it yet? Or is it used in production at all? And apparently Strawberry is used at Yelp, and that's all based off this Yelp engineer who leaked that on Twitter. And yeah, there's actually more signs. There's like this, oh, it's actually him. Oh yeah, I just recognized it's him. So he opens a lot of like issues in our repositories and asking for help, and he's not, I shouldn't say that, but we have a separate category, which is our sponsors, and it's separate from Yep. Anyways, he's nice, and he has really specific requirements for our permission system, which we're discussing for months now, but he also posts job postings on our Discord, which is nice, I guess. Yeah, our sponsors, we have sponsors, which is nice. Open source with sponsors, imagine. They always use it as well. I checked what they were doing. It's funny stuff. There's like a music streaming service for companies. Apparently that's a thing. There's someone who's really into carbon capture technology. Nice stuff. Even a fertilizer manufacturer and distributor. They're apparently market leader in their state. I don't know which state. But yeah, and there's also biosecurity threat management, which is also nice. Now that I think about it, is it so nice that they use Strawberry? Okay, no, it's awesome, it's awesome. Nothing could fail because of the testing. Okay, and apparently there's also some random video game, like an MMORPG, and they use it for everything, and they use WebSockets, which we're also going to talk about. And, well, you technically also used it already because the PyCon Italia website uses Strawberry. And, well, I use it, so that's a good sign, right? And maybe you. I mean, technically, you already used it. OK. Wow, I'm so much slower than I thought. Strawberry uses something called a code-first approach for GraphQL. See, GraphQL always starts with a schema. That's what we see on the left side. That's kind of defining how the GraphQL API looks like. That's independent of any language. It's actually, GraphQL has a language, a schema declaration language. That's what you see on the left. And on the right side, you see how you would do the same thing in Python with Strawberry GraphQL. And what you're supposed to see is that it's the same amount of lines, which is somewhat impressive for Python with decorators and stuff. And it looks roughly the same. You could actually use the definition on the right and run it. It wouldn't do much. It's basically just a definition of types, but there's no data involved yet. And this is all about data at some point. Since this is so similar, we can actually use one of Strawberry's tools to get started, the code generation tool. You can run a command and turn the left side into the right side, so you don't actually have to type it. That's useful if you migrate some other service that's written in GraphQL, but not in Strawberry, and it has a schema. You could just get the schema and then use code generation, and then go from there, and you save a bunch of time. Helps you replicate another schema, for example. Or in our case, we will hopefully use it later to get a quick start on a quick demo. Yeah, but as I said, that schema is somewhat useless, just a definition. There's no way to actually do something meaningful with it other than look at it. And that's where the story fields come into play. So this is what we saw on the right. We have the funny song type, and we have a field on our query which is called songs. That's one way to retrieve all the songs from our API. Obviously, that's a simple example. I just returned a list of songs, which are instances of the song type. And this is what we call a resolver. Like the songs function is resolving that field on the query type. That's what was missing in the slide before, which made it useless, but now it's useful. This will actually already work. Someone is confused, but they will figure it out. Hi. OK. Oh, yeah, that's the new slide I added 5 minutes ago. So you would repeat the same step, not only for the query, because we also have other operations we can do in GraphQL. Like query is retrieving data from the API. If we want to change data, we would use a mutation, which is a separate kind of operation to keep things clean and separated. And then there's a third type, which is called subscription, which is basically you subscribe to some data that is regularly updated, and you don't have to check, did it change? Did it change? You would get notified about it, which is really convenient. And it works the same. You write resolvers for these 3 types, and then you combine them into something called a schema, the GraphQL schema. And that thing is really cool, because it can do everything we want. We can use the schema already to use our whole API, given that we wrote resolvers for it. We can write tests against it. And we can actually run it or serve it using the Strawberry command line interface. It has an inbuilt debug server, and it can serve the schema. So you can actually use it in the web browser, or you could actually use it as your backend. But I wouldn't recommend doing that in production, at least. And it's really nice for demos as well, because that's not that much code. There's something else you can do with your schema. You can add extensions to it. Strawberry has an extension system. It encapsulates like stuff a lot of people need, or which are just handy to have. Like, I don't know, add some tracing to your schema, like check how long do certain resolvers take to retrieve your data or something, or certain queries. Yeah, actually that's profiling, but doesn't really matter. And you could also add some security-related extensions, something like Strawberry. GraphQL is obviously just implementing GraphQL. In GraphQL, you can write enormous queries to retrieve data. And some, well, I guess bad actors could write in a super long or even recursive query to get your server down or bring it to its limits. And you can limit the complexity of queries and stuff like that. And we have extensions for that, so you don't have to write that on yourself. Yeah. What else do we have? More slides. OK, I said that the schema is already super powerful and we can serve it over the browser. That's what we can do. Like you basically just put the code you just saw in a Python file. I call it app.py, and then you run strawberry run server app, and it will look in your app.py file for a schema, and then magically spin up a web server with hot reloading and a super nice interface. And that's really cool to iterate on your schema and try things out. Like you basically just write a schema which is independent of normal web server stuff. It's like really focused on your data and how to get it. And then you can open this nice web interface. It's called GraphQL. I guess some people already heard of it. It allows you to write queries on the left side, and then you press the big pink button and you get your results on the right side. It also supports not just queries, but also the mutations I mentioned, and even the subscriptions. So it's really fun to play with and nice to iterate and experiment. There's alternatives to GraphQL, like other web interfaces you could use. We also support that. We get that question a lot. That's why I'm mentioning it. OK, so after seeing this, we probably feel like, OK, this is probably ready for production. We can already use it, so let's ship it. But the thing you should do before that is testing, which is also fun with Strawberry GraphQL, because that's all you need for like a fully functional test. You basically just import your schema, which already can do anything. And that's a PyTest test. So it's just a function that starts with test underscore, and then you basically just do your test. In our case, we have a query that gets us the titles of all the songs from our backend via the GraphQL API. OK, actually, directly from the GraphQL API. And then you just check that the results match your expectations. So they don't have errors, and that the data returned is exactly what you expect. And you do exactly the same thing with mutations. It's literally the same, except there's no except for your document is not a query, but a mutation. And you can also do the same thing for subscriptions. In that case, you don't get a single result back. You get like an iterable, and you get all the subscription results back over time. What I like to do, which might be controversial, it's at the top of my test files, I have a really big string with queries in it, because I tend to reuse the GraphQL queries in my test a lot. Like, sure, I get all the song titles, but then I test different things. I think I test that it's the right songs. I test the ordering and stuff like that. So instead of rewriting that GraphQL query all the time, I just put them at the top of my file and then reference which query I want to use in my tests. You can see that it says operation name, song titles. I could have put song IDs there instead, but then the test would fail, of course. But that's something you could do. That's a small tip. I don't know. Yeah. Actually, the last test would also fail. The test songs are ranked by popularity, because we don't do that. But I think that's called test-driven development or something. And you can do that as well. OK. So now we're kind of ready to ship our schema to production. And as I said, you shouldn't do that using the cool debug server. You should probably use your favorite web server for it, or web framework. And that's, well, technically all the ones we support. We support ASCII, and that's basically compatible with a whole range of other web servers who support that protocol. So it's even more than this list. And yeah, I hope everyone found their favorite framework or server in there already. There is some check marks to the right of it, which we're going to discuss in a bit, because that's what I'm mainly working on at Strawberry. And that's so-called transport protocols. That's how do you get the data from your backend actually to the client, or how does your client actually contact your backend in an efficient way. And there's several protocols. And, well, most frameworks support all the protocols they can based on their own capabilities. If there's these eyes, it usually means something like, OK, this web server just has no WebSocket support, so we cannot implement the protocols relying on WebSockets. Sometimes, in case of Flask, for example, it means something like that. Flask has no first-party support for WebSockets, at least the last time I checked. They have a really popular library for it, though, but usually we don't do that, at least not as of yet. We rely on first-party WebSocket support in that case. I probably want to say that later. Yeah, let's talk about that later. Okay, this is how an integration looks like. I originally had a Django example because we like to show that a lot, but since Fast API recently became like the most popular backend framework and technically sponsor of this event, I'm showing a Fast API example instead. But that's all it takes. I hope everyone who used Fast API before feels familiar with this code. So you just have your normal Fast API app, and the only thing we add is another router, and it's a router for all the GraphQL stuff. And what we're trying to achieve, like with all the integrations, is that they are kind of idiomatic, like you feel at home, and they try to reuse the patterns your favorite framework uses. Like in case of Fast API, we're using routers, or in case of Django, we're providing a view. Or actually, also in the case of Fast API, we have like integration with their dependency injection system and yeah, stuff like that. You're supposed to feel at home. What's that one? Strawberry Django, yeah. You saw that like big table earlier with the check marks. I was meant to say that it doesn't really matter which integration you use, they're all kind of equal. They actually use the same base class in Strawberry, so they're all tested and maintained the same way. There's one integration that's a bit different. And that's in case you use Django, you definitely want to use a package called Strawberry Django, or Strawberry GraphQL Django. That's, I guess, the official name. And it comes with a bit more than just a view integration. It has an integration with the whole Django model system, which makes it extremely powerful because it enables you to define your Strawberry types in a compatible way with your database models. And I guess the biggest part is what Thiago, he's actually the author of that library, would call query optimization. Since you can get any kind of request to your GraphQL API, you have, like, potentially you have to ask your database a lot about where to get data from. Like, you do a lot of database calls from different resolvers, and there's techniques to combine them into one single call. But if you want to be like really efficient, you probably should use Django and the query optimizer because it already knows what you are asking for and where to get it from. And using Django magic, it can ask the Django object relation mapper just to return that and have like a super efficient query to your database as well. So you don't have to do the optimization, the package does it for you. There's actually so much more. A lot of people like the debug toolbar in Django, and it's also integrated here as well, so you can actually verify that the optimizations are working, or if you have to give some extra hints. It's also integrated with like the filtering sorting system of Django, and well, you read the slides by now. Okay, let's go back to the transport protocols. So this is a scary slide. Like, I talk about it because I implemented it and I'm most comfortable with. And there's some fun things here that most people don't know, maybe even Thiago. As a backend developer, you don't really have to care about this. Actually, you do, but also note. The thing is, so these are the transport protocols, and Strawberry has enabled almost all of them by default. So whatever your clients are speaking is already supported. So you just write your resolvers and it will just work. But since you're probably the same, like if you're a backend developer, you're supporting your clients in some way, and maybe you want to remind them to use a cool protocol because then they will be more efficient. But since that's implemented in backend, we're going to look at it. There's different ways how your clients can get data from your backend and how you're serving it. You can do it via HTTP or WebSockets, and there's various sub-protocols on, like for achieving specific things. The most common one is GraphQL over HTTP. It's just send a request with what you need and you will get it back. You can use it for queries and mutations, so you can get data and you can change data, but you cannot subscribe to data because you have to ask to get an answer and you will never know when the data in the backend updated. There's multi-part requests. They're mainly for file uploads. I wouldn't recommend that, but I will say something about that in a bit. There's multi-part subscriptions, which is a new protocol, so it's kind of an easy protocol, and it's, well, abusing multi-part, but I'm going to talk about that in a bit. And, well, there's WebSockets, which look really fancy on the slides, and they kind of are, and that's why I'm working on WebSockets all the time, because you can do all the operations via one protocol. Let's look at them a bit more. So that's the most common one, the GraphQL over HTTP. You can send post and GET requests. Post requests are the most common. It's like the default HTTP method for GraphQL. You can do queries and mutations with that. Some people like to do GET requests, but they're only supported for queries. I would just avoid that, but you can do that. That's just an example how a post body in HTTP would look like. You don't need to know that, but I like to have pictures on my slides. Oh, it's that one. OK. If you want subscriptions and you want to stay in the whole HTTP realm, you can use what's called multipart subscriptions. That's actually our latest addition to Strawberry. It's a new protocol by Apollo, and it makes use of the fact that with multipart requests, your response has multiple parts, and they can arrive over time. And normally use that to upload like multiple files to a server or download whatever, but we can use it to receive events over time. It's a funny hack. It's actually a nice protocol. That's a thing. Don't have to worry about the details. There's also what's called a GraphQL multipart request specification. I'm always looking up there because internally we call them differently. This for us would be upload support. It's the only transport protocol that's disabled by default for some reason. It might have been our first security incident, which has been resolved, so everyone calm down. But I would recommend leaving it disabled. And Patrick is like, what do you mean? I'm using it for my one side project. He actually does, but in the future, it will be safe to use. We came up with a protection mechanism, which I just haven't created pull request yet. Yeah, in case you want to use it now, you have to be aware of some really niche browser policy. It's actually not that niche. It's like the CORS protection for like cross-site requests, which you probably don't want to have. And there's some edge case where a multipart upload is not checked by your browser, so someone could do some bad stuff. We don't protect against it by default because it's really hard to do that, like adding something on top of the schema to protect you against that. It's usually the job of your web framework, and all the web frameworks have protection for that. Like in Django, for example, it's the CSRF protection view decorative thingy. You just add that to your Strawberry thingy and then follow their documentation. It's just not protected by default. It's something you have to do, and that's why we disable it by default, so you don't accidentally use it without knowing about that. Yeah, but this protocol is nice for like if you need file uploads and you want to upload them directly to your GraphQL server. There's better alternatives. Like in any case, you probably just want to upload it to like S3 or some compatible service instead with pre-signed URLs, because if someone uploads like a super big file, you will run into trouble because your server will read the whole file, and depending on how much memory your server has, it will, well, either handle that nicely or it doesn't. There's some benefits to it, but they're really small compared to the disadvantages, which is, sure, you can have uploads in your GraphQL schema, and then you have like one API for everything, and your clients only have to use this one endpoint to handle everything. Well, you decide. Okay. Oh, I have the warning first. Yeah, we are coming to the WebSockets. And we have this warning everywhere. We have it in Discord, we have it on various issues on our GitHub, and we also have it in the documentation because someone did something funny. There's an old protocol which no one should use, and then there's a new one. And there's some overlap in the naming. Like the new protocol's GitHub repository is called GraphQL WS. But that's also the name of the old protocol. So whenever we refer to the old protocol, everyone thinks we're dropping support for the new protocol, and then everyone complains. We started calling it the legacy in the modern protocol just to avoid that whole thingy. So if you read our documentation and you get confused, then just remember there's something weird, and we know what we're doing. It's not a typo. It's just the new protocol is going nowhere. Oh, nice. Oh, maybe I don't have to do a demo. OK. Yeah, that's the old protocol. It has been deprecated. It's archived on GitHub. No one should use it. The protocol is horrible. And I can say that because I had to implement it, and I'm maintaining it. And there's so many gaps in the specification. It's like, do something. And they put a random word there which doesn't make sense. And then you look in the reference implementation, and they're like, And that's what we do. We do the same, so it looks like it's on purpose. Just don't worry about it and don't use it. And I wish everyone did that, because it's still downloaded almost as much as the new protocol. That's why we haven't removed it yet, because apparently someone uses it. Yeah, and then there's the new protocol, which is nice and shiny. It has an actively extended, well, that's wrong. It has a specification, and it's still getting updated whenever a new need or edge case arises. It supports all the GraphQL operations, so you can retrieve data with it, you can change data, and you can subscribe to data. And that's really cool, because your clients can just use WebSockets for everything. So they just have one WebSocket connection to your server, and they can send everything through that one connection. So if you need a lot of data in your app, for example, you can just avoid having to go through the whole overhead of starting a new HTTP request, for example, because you only have to do that once, and then you keep it alive for, well, however your client is using their app or website or whatever. There's one thing to think about, which we didn't think about. Some web servers send WebSocket ping-pong request messages by default. That's something to keep the connection alive. And AIO HTTP does that. Some other frameworks do that, but some don't. I don't know which ones, but we should probably add that to the documentation. Some don't, so in case you run into trouble because your connection cuts off, then it's probably ping-pong, and you should add that. Yeah. Oh, shit. Oops, sorry. Do I do a live demo? How much time is left? Easy, because Strawberry is so enjoyable. I can do that. Maybe I do the other slides first, and then we do the live demo. No, we skipped that one. But we do this one, because that's how I ended up here eventually. So if you like using Strawberry, did I move this? Or you liked what you saw and you want to try it, instead of reading the documentation and complaining about something by creating an issue, you could just create a pull request instead and fix that issue. Because we don't read the documentary that often anymore, because we just know it. But people who get started are actually the perfect candidates to become new contributors, because you find an error in the documentation, or you tried something, it doesn't work, but you're smart enough to figure it out yourself. Then don't create an issue saying, hey, this doesn't work and this is the solution. Create a pull request and fix that, because in that moment, you're the expert on that specific issue. And then a lot of nice things happen, and maybe next PyCon, you will be here and better prepared for your presentation. If you create a pull request, then something magically happens if you merge it, or it's getting merged, then our bot will harass you a little bit and ask you for your address. Sounds wrong. But yeah, Patrick set that up, and if you contribute something, then there's a form you can actually import your address, and he will ship you really nice stickers. I actually don't have one, but because I never did that. But as far as I remember, you will get a Strawberry recipe and a thank you letter, which most open source projects probably don't do because it's expensive, but I don't know, we do it anyways. And you get invited to our GitHub organization. That means on your profile, there will be a really cool badge, and it looks like you achieved something, which you actually did. And so I recommend doing that. OK, now it's probably 5 minutes. Is it? 3? Easy. OK, it's not easy, but we can try a bit. How do I exit this? What could go wrong if I click this? OK, no, my notes are gone. Awesome. Nope. back. Okay, so I will break my neck doing live coding. Let's see. Oh, I'm not seeing anything. It's over there. Help. Okay, so this is just a blank repository. It's actually not even a repository. It's just a blank folder, and that's VS Code. Ah, nice. And maybe we just look at how to get started. So you probably just want to initialize your project in some way. I'm using a package manager. That's usually a good idea. At this conference, you probably heard a lot about UV because it's so fancy. That's probably too small, and it's not really getting better. But if you run UV init, then you have a project now, which is awesome. And all you need to get started is this command that looks longer than it actually is. It's just adding Strawberry GraphQL and the debug server, which is this fancy thing we saw right at the beginning that allows you to run that fancy web interface, which allows you to directly use your schema in a meaningful way. So we're just going to add that. Is it actually going to download that? OK, no. OK, that's probably enough for today. So now we have that. And what we could do now is write a schema. Am I going to do that from scratch? Probably not. Let me copy that over. I don't see my mouse. Is it over there? OK. Hang tight. I have a backup folder somewhere, and it has a schema. That's awesome. Let's just put it in here. Ta-da! That's how you get started. Just copy it from your pre-made backup folder. OK. Oh my God, it's everything. OK, this demo is already flawed. OK. Yeah, that's a schema with everything in it, which is a bit too far because, well, I'm probably just going to show you how things work. OK, what I have here is something should be familiar. So this is the song type we saw earlier. Down here, we have the query type and also the resolver for songs, which I used at some point. The first people will probably notice that there's a duplication which I could fix by just returning songs here, which I forgot. And there's also the play song mutation, which we saw on the slides, but it has an implementation here. And there's also a subscription implementation. Originally, I was planning to show you how to do that from scratch, but since most of this is just bad demo code you shouldn't run anyways, it probably doesn't matter too much. So I'm just going to show you that this is already all you need and that our debug server is really great. So if you do Strawberry, does it say Strawberry over there? Probably not. Strawberry server schema. Schema is the name of the file, except for the file extension. If you run that, then it should spin up a web server. Yeah, and there's a URL. You can just click it, and it hopefully opens them. Oh, it's on the screen. Come over there. Then it will open GraphQL, which is all you need to work with this schema. You could, for example, I pre-wrote this earlier, no, I'm glad I did. You could run the song playing query and would say null, because we're obviously not playing any songs. But if I run the play song mutation, then we suddenly get something back. And if I run the first query again, I get the same thing. I could also play another song. No, it's song 1, and if I play it again, it's the same thing. So that kind of makes sense, I hope. But that's not really impressive, because everyone wants to see the subscriptions working, and I hope they will work. If I open the same thing in another browser, I don't see anything. There's no subscriptions anywhere. Awesome. So we're going to write a subscription. What we can do in this one browser is not a query, but a subscription. There's autocompletion. Song something. We are all dying inside together right now, by the way. So I have a subscription. It's called Song Playing, and it subscribes you to whatever song is playing at the moment. You can think about Spotify, for example. If you have multiple devices, like your phone and your desktop, and you play a song on one device, the other device will show you. That could be something like that. So if I want to show what song is currently playing, I could subscribe to the currently playing song subscription, and it would say whatever it says. That's the song we started playing earlier. And as soon as I use the mutation over here to switch the song to like song 3, I should have used cooler names, then it will immediately notify your other browser tab or your other client. Nice. Yeah, and that's Strawberry GraphQL. Ha! It said game over, so I stopped.
You can continue a little bit.
Nah, it doesn't matter. No one wants to see the code. Like, there's many ways to do it, and the variant I chose is using async IO events. So the subscriber is just waiting in a loop, basically, but then it's pausing and waiting for an event which is triggered by the mutation to like check what's the currently playing song, and that's why it's so fast. Everyone who knows, knows, and everyone else is just going to stay confused. Yeah.
Okay, thank you very much. And so it's Q&A time. And we have some questions. Okay. Okay, this one is, do you think Strawberry should also work as a client for tests and also use other GraphQL APIs from Python?
That's a good question. To some extent, we do some things like that. We are all questioning Patrick's decision to do that, but there's two things. He's like, what are you talking about? One of them is our code generation tool can already help with generating client code to query the API. So that's one thing. I think it even supports TypeScript generation and stuff like that. So we already have that. And the other one regarding testing, that's funny. We have an internal test client we use for our own tests. And it turns out some people found that, and they use it in their tests as well. And apparently it's quite convenient. I wouldn't recommend using it because it's not designed for that. But since we got, well, yeah, okay. Like there's some things I want to change, but I think that's definitely something we want to offer. Turning it into a complete client library is probably not really necessary, because I wrote one, which is not Strawberry. You can use that instead. And there's another popular one for that already. I don't know. Do you have any ideas for Strawberry as a client library? There's not really a need, is there?
Yeah. No, I mean, I would love to see something that's like GraphQL without all the content.
Yeah. More magic. Maybe we will add more magic. Yeah. Yeah, good point.
You can talk about it outside more.
Yeah, yeah.
So
whoever asked that can join in and contribute.
Next question. Wouldn't it be too heavy to use WebSockets for everything?
Well, depends. If it's like an extremely data-heavy application that would instead send a lot of requests for some reason, or has to do polling instead to get updated data, especially if you use subscriptions. Like, I would recommend send everything over WebSocket if you're using a WebSocket for subscriptions already. If you don't use subscriptions, then sure, go with HTTP requests, because GraphQL is designed to only run a few requests to get all the data you need at once. In that case, don't use a WebSocket.
Okay. And do you support SSE, server-sent events?
There was a slide for it, but I skipped it. We don't support it yet. We looked at it for a long time. I think there's some prototyping happening. Like, I think you teased it on LinkedIn. Oh, okay. Oh, yeah, good point. Yeah, I have my eye on it. I was waiting for the specification for it to feel somehow like more complete, so I don't have to change it all the time. But yeah, that's the next protocol we're going to add.
Okay. And can you talk a bit about Differ? When is it coming?
Do you want to say something about it? Man, I only know it from the protocol's perspective from the WebSocket side, so there's, yeah, no, you talk about it. It's a better idea.
Sorry. Yeah, Defer is a way to basically have a single query like that one. Imagine if it's huge with a lot of fields. But if you don't need some of those, like immediately when you receive the first request, you can defer them to later. So you first receive, for example, in the song, you can receive the ID and the title, and then, I don't know, like comments or things like that can come in a subsequent requests. It uses the multi-part protocol that we have.
Yeah.
And so it makes your app a bit faster because it shows the initial information as soon as possible, and then the additional information like later. And it's coming maybe soon. Yeah, like the implementation is pretty much done. We just need more testing, and we're also waiting on the one library that we use that's in alpha, but it should be no alpha soon. Yeah.
Yeah. And I also want to add it to the website.
No pressure there. Okay, I think our time is up, and if you have any other questions, I'm sure all of our hosts will be available to answer. And thank you very much.